with working with some of our client software at Nthought, working with large data sets, obviously you need to be aware of memory usage throughout running the algorithm, and sometimes design very carefully around large memory usage. So obviously you can have problems with memory leaks that you need to find, but the problem that we really had to deal with, and the reason we created Pikos, was there was a very large allocation of a temporary object that just brought the entire system down. And that's a little bit harder to find than a memory leak as well. So we tried to investigate solutions that we could use to find this problem, but couldn't come across anything at the time, so started with Pikos to locate the problem. After the fact, we did find something that could have helped, but so beginning of Pikos, we needed to find memory leaks and temporary allocation, large temporary allocation, in a largely unknown code base, because the computation core was written by the client, not by Nthought, so we didn't have a huge knowledge of the code that we were working with at the time. And tracing the execution rather than just periodic monitoring of memory, which a number of tools do, because if you've got temporary allocation, is usually a very short time spike of memory, but can be a big enough spike to pollute the address space to such an extent that you land up with a seg fault and no useful information to track down the problem. So initially, we just recorded values in a CSV file that we could plot at a later time and just use that to locate the problems, which so not very real time. That's a recent addition that I'll get to a little bit later. So to look at how you use it, it's pretty simple, although it can be improved quite a lot. Instantiate a recorder, which is what actually deals with results, a monitor which will produce results. So you can see here I've got the monitor and recorder together, and that just goes into a decorator that will just set up all the machinery when the function is called that you want to profile. So, well, we've got just a simple problem that produces a large temporary array, a bit of a memory spike, which the output of that, we get some numbers in a table that's not very easy to look at. You can see down in call number 37, we get a spike of a couple hundred megabytes, which is the problem that we want to eliminate here. And we trace that further up to the line in our source file where we've got the problem, and we can go and fix that. Another reason why we wanted to create Pikos was to produce slightly easier to look at output. So much easier than trying to scan a list of numbers. You get a graph that you can easily see the problems. So existing tools, I mentioned that we came across something that we could have used, which was Memory Profiler. But before that, tried to investigate using Heapy and Melior, which both give very detailed, very useful analysis of how memory is allocated in a Python program. For example, with Heapy, you can connect to a running application and collect information about objects in the process and drill down to possibly where they were allocated. But problems, it is very slow when you've got a large amount of memory usage. I tried to run it once on a 7 gigabyte allocated process, and it took a few hours running overnight. It's slightly difficult to use in that situation. So if you can narrow it down a bit, before using a detailed analysis tool, I think it's very useful. And then memory profiler is line by line. In Pikos, we've implemented just by function call, like you get similar output from cprofile. Memory profiler is, it traces every line and collects memory usage information. I think it can be improved slightly, but it's also a very useful tool, and we plan to wrap that with Pikos so you can do the same sort of analysis with the line-by-line profiler. So after our first use of Pikos, we needed to use it with some other projects, and it needed to improve a bit, generalize the concepts, and just make it a pluggable architecture. And well, that's the code I showed you earlier was from more recent, was originally tied very closely to a customer project, so not very useful. So this is just a monitor that can be used with, it's the decorator for the function that you want to profile, can be used with any of the implemented machinery in Pikos. A logger is what is given to a logger that actually goes in and records useful information, or produces useful information. So, for example, memory usage before and after a function call. You could also use it as a replacement for cprofile doing timing, but obviously cprofile exists. Then the recorder, I think, is what gives it most of its flexibility. You can easily just plug together any output stream, so you can print it to standard out immediately, or send it to 0MQ socket for live plotting, which is, I'll show you later, it's my favorite feature. Or if you want to do both, it's trivial to just create a composite recorder that will just do both of those. So like I said, they can plug together in a very simple way, very flexible and easily extensible. So I've already mentioned most of this. So logging, we initially did it to profile memory usage. There's a simple thing that just prints the program flow similar to trace.py included in the standard library. And profile speed, we've actually got a simple wrapper around cprofile. Needs a little bit of extension to cprofile to do the real-time analysis, but we'll get there hopefully quite soon. And recording functions I have already spoken about. So real-time analysis, I think, is probably, well, for me, the most useful thing when you're working with a large, long-running simulation. Just getting results as they happen can save quite a lot of time. So currently it's just a very simple user interface around the real-time thing that I've actually put together mostly in the last couple of days. It lets you see a little bit of information about the function calls in the user interface. So it's not more than just the graph I showed earlier. So actually at this stage I want to give it a little bit of a demonstration, so that was already running, and so if I start monitoring an application I've got running in the background that randomly allocates temporary arrays and also randomly leaks a little bit, probably until it segfaults. You can see 3.5 gigabytes and counting. And no, it's not quite segfaulted. That's probably it done. So I can click on any of these points and get a little bit of information. I can see the file that had happened, the function that was called, and memory usage. So I can well, that's not a very useful view, so I can drill down a little bit and find so my actual allocation, well, the interesting part was a few points back where, so yeah, that bad add to array there allocates a temporary, and then it goes into NumPy and the actual allocation happens. So that's certainly my favorite part. And I've got plans to extend the C profile to put out results live like this through 0MQ, so you can watch speed profiling live. And similar things for line profiler and that line-by-line memory profiler I plan to extend to be able to work directly with this. So improvements to real-time analysis, so there's only a very limited set of information there available at the moment. So I'd also like to be able to process multiple things at the same time, which using 0MQ we've got transparent network transport, so you can have, I was talking to somebody here today who runs jobs on a distributed computing cluster. You could have each of those send profiling information back to your workstation and watch the information live from multiple processes. So I plan to do that shortly, which best parts, BSD, anybody can use it, and as of yesterday it is public on GitHub at that URL. It'll soon move to be under the Nthought umbrella, but not quite got there yet. And I'm afraid that was a little bit of a lightning talk. But questions?
Yeah, so obviously you've got a bit of an emphasis on performance. Have you managed to keep the impact of the monitoring quite low?
I'd like to get it lower, because certainly with the number of classes we've got in there, so there's the logger and the recorder, and there's optional record filtering, so if you know you're only interested in, say, certain types, only C calls rather than Python calls, you can have filtering. So there are quite a lot of function calls in there that I'd like to try to eliminate. And it's all pure Python, so another step would be to Cythonize that and go through the C API. Yeah. Yes?
Say, for example, I got a quad-core computer, and I'm running 4 multiprocessing processes, multiprocessing module, and each of them is using the profiling algorithm. So is it possible to merge the 4 log files, or do I get a single log file?
So when I work on the multiple process profiling, everything will be keyed by process ID, and they'll each be separate.
So separate log files.
Yeah.
And if I want to analyze as a whole how the system is doing, I would have to merge the 4.
Then I'd like you to create an issue on GitHub and give me ideas. So it's not there. Yeah.
And I felt that the merging part or looking into multiple log files was always a problem.
Yeah, I actually have no idea how we might do that in a useful way. So if anybody's got ideas, that would be fantastic. Yep. It probably will not produce very useful output at the moment. So you'll get something that looked similar to that linear time plot, and things will probably be out of order when your greenlit switch. So I don't know if it's easy. I'm sure it's possible, and that's thanks for the idea. It's something I'll put some time into and look into. Yep.
So is the C profile stuff just a dream at the moment, or have you made progress?
Well, let's get a console up here. Where's my console gone? So I can show you.
The GUI, is it going to be cross-platform?
It is cross-platform. It's Traits UI, so. It's a simple wrapper around either WX or Qt, depending on your preferences. So yeah. So what we have with cProfile at the moment is it just runs cProfile like that and gives you the results at the end, which is why we'll need to override a few of the internals to just produce real-time results. Yeah, it's going to be a lot easier with memory profiler because that's pure Python. So still not quite sure how I'm going to do that with cProfile. It might need a little bit of a fork.
It's a really interesting idea.
So it's something I plan to work on very soon. So I think that's like having both memory profiling and speed profiling in real time, I think is very useful. So anything else? Yep.
So you mentioned that when you tried using it's too slow for you. Is that because you have to wait for the whole simulation to finish?
So the problem that I had at the time was just the time that it took for. So I had a simulation that had already done. That was that application was just actually reading data and then displaying it. It was not running a simulation. It was just Heapy was taking a lot of time to collect its results.
Is that because it's basically profiling everything
Yes. Yeah, it's collecting results across the whole set of the heap allocated memory. At the moment, just for development, because you saw was quite pervasive getting it in. This code, it's quite pervasive. You've got to create your logger and decorate the functions. So at the moment, it's strictly development. I had an idea from somebody recently that we should be able to switch it on and off somehow in a running process, which is something I'd like to look into, because particularly running distributed jobs, and if you see something starting to go wrong, it'd be nice to be able to switch it on and look into it rather than have to rerun everything and hope it goes wrong again. You can analyze it.
So a lot of the time I've spent having to try to debug things that blow up the memory, especially if it's code that I'm totally not familiar with, which is often the case, is that in this case, you're very lucky because once you hit the numpy call, that's where the memory explodes, and everything underneath of that, works okay. So you can make the safe assumption that the programmer who implemented that is the one that did something crazy, but there's nothing wrong with, let's say, the numpy package. I wonder, I was just theorizing on how hard this would be to do, but if you could decorate on the top level function, if it could give you a stack level picture of how much memory can allocate, because I find myself oftentimes putting a lot of full statements with memory usage just to isolate down to this point where I can then look at the decorator and say, show me what's going on.
So yeah, there's absolutely no problem with running the whole application through it. It'll slow down execution by a number of times, but
Oh, so it's not limited to the lines in this particular function, it'll actually go through everything.
so yeah,
Execution.
which do I still have this here? So like well, let me get the code up for this. So the entry point, the entry point is down here, but in that graph, so there's not very many function calls here. In that graph, I've got all of these calls to make array, make bad array you saw earlier, and also you can see the C calls into NumPy as well. So it does trace down into the calls. So you can put one top level and get all of the results through the application.
Yeah, that would be a huge time saver because it can be random code anywhere sometimes. That's I could just using incorrectly. It could be somebody else's code.
Yeah. So yeah, that bad allocation of the allocation of a temporary array that I showed, sort of very simple problem, was the real problem that we had in the client project. Was just a copy that didn't need to be there, and allocating about 2 gigabytes of memory and crashing. So, is there anything else? Okay, thank you.